So we've talked about transformers a couple of times, and I brought them in, and I keep saying I'm going to tear one apart so you can see it. So today I had this bright idea to use my CAD, computer-aided design package. This is Autodesk Inventor, to show you how the transformer is made. So first of all, we've talked about these metal plates here. So well, here they are. They're very thin. So these are about 2 inches by 2 inches, I believe. Let's take a look. And sure. So 80 millimeters. So 3 inches high. And let's see how wide it is. And length of the edge, yeah, about 4 inches. Okay. So these are made of what's called permeable metal, but it's easy enough to think of it as iron or some kind of soft steel. And they're painted with some kind of very thin, non-conducting enamel, usually clear. And then there's a sandwich made first. One on top of this one, and another one. Notice how they're alternating. This is not 100% sure that's how they do it, but for sure it's made of these layers. And I will talk about, we have talked about the reason, but I'll give a more detailed reason at the end. So you can admire my CAD program. So at the end of the day, we end up with a whole bunch of them. In fact, for some reason there's 59 of each. I don't know why not 60. I just downloaded a model from the web, and then I redid it, tore it apart, and reconstructed it. So anyways, that's what we start with. So next, we have to make a coil assembly. So this is very stylized. And so you'd have some kind of inner part, might call it a mandrel. Mandrel's just a physical thing. And then you're going to wind wires around it, coil wires. And probably these are much thinner wire as comparison to the overall dimensions here. And not only are there all these coils, there's probably multiple layers. Depends on what you want to do, the number of loops in the area, and there's a relationship with these, whether you want it to be a step up or step down transformer. Sometimes you make them 1-to-1, and that's just to eliminate a DC coupling. And then there's another mandrel, or maybe just waxy paper is put over that. And then you wind more, wind. I made these out of colors, and they're somewhat transparent, so we can see what's going on. And we're not paying any attention to these leads at the end. They would be routed outside, but there's too much trouble to alter this model. And then some kind of outer wrapping, which we see in the outside world. So that's the coils, ready to go. And then in a similar fashion, we have to make the pieces to make an assembly that's going to cap this off when it's finished. So this is sort of my imagination. Oh, and again, these plates are only 1/2 millimeter thick. Let's see. Yeah, same thing here. They're just 1/2 millimeter thick. That's why there's so many of them. Okay, so then we can imagine coming up with something like this. Although without any screws in it, it's probably difficult to hold this together. But anyways, for the moment, just imagine this thing will ultimately be made. All right, and so then here we have our assembly, and we can take it apart. And so we'd have this bit here. If we were manufacturing them, somebody would first put this together. Somebody else would have made the coils. And one can imagine this being loosely bolted together because we need to get this top piece in. So really, it's quite simple. You just drop that in like that. And then one imagines, instead of bringing this down as an assembly, one actually imagines bringing these plates in one at a time, and one by one placing them in there, like so. And then, of course, you bolt it together, and you have yourself a transformer. And of course, you would have wires sticking out of it, as we've already seen. And in this case, you would have, this one has feet. They usually have something like that to mount them. Sometimes the wires just come straight out so they can be attached to a circuit board. Okay, so why do we need this to look like this? And why do we make it of those thin plates? And why do we put the thin plates and cover them with some kind of clear paint or enamel? So you can imagine that these coils are in here. Remember, they're having AC, alternating current through them. So you have the north and the south constantly changing. And of course, we know that the one coil will induce a current in the other one. And then remember, then that means then in this dimension here, so north is going to come up. And remember, north field lines have to find south field lines. So this, we call this is flux return metal. So the north would come up through here, go to the left, come down, and come around and come back in the south, or it would come around like this, and so on. So when north is facing upwards, then you think of clockwise flow of the flux lines this way, and sort of a counterclockwise orientation in that way. So great. And then every time the current flips direction, the B field goes in the other direction. And that's wonderful. And as we've seen in class, having this metal in between intensifies their effect. However, there is an issue going on. So let's take a look at this. And I'm going to freeze this in place. There it is. And then I have this current loop here that I'm going to make visible again. So let's just think about this. Remember now, the north and the south is going to be flowing along this direction, back and forth, back and forth. And this is made of metal, so metal can conduct electricity. So if I make believe that I've got this current loop here, you can imagine that when the north and south B field is moving in and out here, so it's going to be basically in and out of the page in this orientation, there's going to be an induced current in this loop. And of course, by Lenz's law, the B field induced is going to fight the change in the B field in these plates. And of course, if you think about it for a minute, that would be bad, because then it would make a kind of effective resistance, like in the motor that we looked at. And so that's bad. And that's why we make these little plates and why they're coated in epoxy, because then no current can flow in this from left to right here in these plates. So that means you'll never get a current loop. You'd get, at most, tiny little current loops in the plates, but the amount of magnetic field that they would make compared to the applied magnetic field from the coils would be trivial. And that's why it's done, so as to cut down those currents. And another thing that would happen if those currents would flow, and you would have these plates heating up, they would flex more, and the transformer would have a shorter lifetime. In fact, that's what eventually kills these things, because the changing magnetic fields causes these wires to flex a little bit, and they rub a little bit, and then eventually they're also coated in kind of an enamel, this reddish enamel, and if they rub together, they start shorting to each other. And then the resistance goes down to heat them up, and then this waxy paper starts melting, blah blah. That's why you put your nose, open up an old radio, and you smell a strange smell, and that's from the transformers. All right, there you go.